Well, hello everyone. Today I would like to talk about random forest. As you all know, we have introduced new predictive analytics module in Minitab, and the random forest is one of the power tools that you can add into your predictive analytics toolset. What is random forest? Well, the random forest is basically, it's centered around building large number of independent individual either regression or classification trees using bootstrap aggregation. Now, why do we need random forest? The main important part here is that the random forest allows you to dramatically improve overall performance of your predictive models. Okay, so let me show what it means. I have a data set here that gathers information about the energy output in megawatts of a solar power plant. And you have a time of day here in the military scale. You have sun elevation in degrees, sun direction, temperature, precipitation, cloud cover, humidity, wind speed, wind direction, and barometric pressure. So what we want to predict here, we want to predict the energy output of the power plant based on all of these geographic and weather characteristics. Now, why is that important? Well, as you know, a power plant usually is a part of a power grid, and depending on the conditions that we are forecasting for tomorrow, we are going to have different output, and therefore, depending on the demands of the grid, it's very important to understand exactly what kind of power output we are to expect, right? Because then we could take certain different measures to deal with it. So the more accurate the prediction is going to be, the more is the business success of this particular problem and its solution. So let me show you the histogram of the energy here. As you can see, it varies because the data collects hourly power output for the entire year. And if I were to build a conventional regression analysis, notice my overall equation would be presented here. So there's a lot of different coefficients to look at because I'm looking at the mixture of continuous and some nominal variables. And if I were to look at the overall performance, I'm getting about 70% R squared on the test sample. In other words, there is still 22% of power output fluctuation that I cannot capture, cannot predict using this particular regression model, doing it a conventional multiple linear regression way. Well, let me switch to random forest here and show you what that exact same setup would give me if I were to run random forest. Well, in this case, what you will see is that random forest off the bat gives me 87% accuracy on the test sample. That's a whopping 12-13 points increase, right? So it's a much better performance than I had before. Well, let me have a look for the regression. We were getting 78%, and now we're getting 87%, right? So it's a 9 points improvement performance-wise compared to what I get with the classical conventional multiple linear regression. And in addition to that, random forest also ranked all of the variables according to their contribution. So now I know that if I look at the sun elevation, that is the most important driver. Well, it kind of makes sense when we work with solar power plants, right? But when you look at all these others, you can also see that cloud cover is the next important one, humidity is the next important one, and interestingly enough, wind direction and wind speed ended up being towards the bottom of the list here. So now, as you can see, very quickly I managed to build a regression model that is drastically outperforming conventional regression, and it gives me additional pieces of information that I can look at and I can study. So this is what you can expect more often than not when you run random forest in a regression setting. Now, random forest is powerful enough to handle not only regression but also binary and multinomial classification. Let me show you an example of binary classification. There is a data set here that deals with bank marketing. And in the bank marketing, there's a collection of records where we have observed who responded and who did not respond to a certain bank offer to subscribe to some kind of business product. And we also gathered up for each contact information about that particular person, the contact type, whether they have a business loan and other things, etc., etc. So again, our main objective here is try to predict a specific business outcome in the binary classification setting. Now, if I were to build a binary logistic regression, let me show it here. So binary logistic regression would give me area under ROC curve, which is what is normally used as a performance criterion in this class of applications, is about 74 and a half, right? 0.745. And if you were to look at the actual equation, you would get this convoluted collection of numbers, etc., etc., etc. So it's not easy to understand, right? Because you would have to look at a lot of numbers, a lot of coefficients, a lot of these different things. Not the most intuitive way to understand what's going on. Now, you could build a cart model to get a better structure that I showed in another video, or if you're interested in the ultimate accuracy, you can go ahead and try to build a random forest model. And here's what happens when you build a random forest model. Again, off the bat, when you look at the area under ROC curve, it jumped to almost 77%. Now we go from 74.5 to 77. Well, in this case, it's not as dramatic as in that energy example, but it's still quite substantial. And in many business applications, if you can squeeze out extra percentage point out of your ROC performance, could mean a lot of money saved or a lot of additional profit and revenue to be made. So this is the kind of scenario that we have in classification. And again, notice random forest showed you relative variable importance. So all of these things are now ranked. And as you can see, contact month turns out to be the most important driver that separates different responders and a different response rate, followed by how many days have been since previous contact, followed by the age of the person, and followed by contact type and some other characteristics of the account. So as you can see, regardless whether you have regression or classification problem, random forest has all of these capabilities to produce a much better performing models for you, which depending on the application will be exactly what you're looking for. And it also gives you some additional insights into the structure. Now, what you do not get from random forest, you do not get a more detailed description of how the predictions are made. Okay, so for that, in the case of classical regression, you would have to look at the actual equations. Or if you were to run a single cart tree, whether it's regression or classification, the tree itself would show you a set of rules that lead to different outcomes. In the random forest, you have a large collection of a large number of independently grown trees, and the power of that collection comes as an ensemble. So you will not be able to understand the intricacies of internal connections, but you will gain additional benefit of getting superior accuracy. And finally, if you want to get both, if you want both accuracy and some additional insights into the internals and the dependencies, for that you would have to go to stochastic gradient boosting, which I will discuss in a different video. So take it, use it, enjoy it, and see what kind of insights and what kind of accuracy you can achieve on your own data using these modern predictive analytics data-driven tools.